Welcome to my video. This is going to be a walkthrough of the NovaCart machine on the HackSmarter platform. It's a hard Active Directory challenge lab. I have completed the lab already, so all I'm going to be doing is walking through my steps, using my notes, and just copying and pasting commands. That way you don't have to watch me type and make a bunch of mistakes. Now, the official walkthrough for this lab does have a lot of steps in it. But what I'm going to be doing is an alternative path to domain compromise, which has a lot fewer steps and won't take as long. What we're given is VPN access. I'm already connected to the VPN. No credentials and a list of open ports. Normally I would do an nmap scan, but to save time, I'm just going to go with this list. Looks like a web app on port 80, another one on port 5000, and also port 8080. So let's get started. If I'm on a Windows machine, the first thing I like to do is run Netexec. Run the Netexec SMB command on the IP address, and that will confirm whether or not it's a Windows machine, what version of Windows we're running, and whether it's joined to a domain. We can see we're on Windows 10 or Server 2019 on the NovaCart.local domain. After that, I update my hosts file so that domain names will be resolved correctly. To do that, I use Netexec again with the generate host file command, running it as sudo, and that will append the host's entry for this machine to the host file. And you can confirm that by just tailing out the file. And we can see at the end, there's the IP address and the DNS entry for this IP. Next, I'm going to create a krb5.conf file. That's something you're going to need for Kerberos authentication. And again, Netexec will do that. We can cat out the file and confirm that it looks correct. Now we can get on with some SQL injection. Look at the website. There is a web page on port 80. Doesn't have a lot of functionality. There's an explore button that doesn't work, and there's a shop now button. We go to shop now, it looks like a shop with a search box. The only thing that really works on this page is the search box. So I can search for laptop, click on search, and it shows me all results that contain the word laptop. If I look for alien, hit search, there's an Alienware laptop. Probably these results are coming from a database. One thing we can do to see if it is indeed an SQL database that's vulnerable to SQL injection is put a single quotation mark at the end, click search, and that gives us an error. That's a good sign that it's SQL injectable. We can confirm that by writing an SQL statement like or 1 equals 1, followed by a comment to terminate the statement, and a space, and another hyphen. So we can see that we have a space there. We do need a space after this minus sign. So this should show all the entries if this is indeed SQL injectable, which it looks like it is. Now, to automate the process of SQL injection, we can use SQL map. We'll run this SQL map command. It's going to take the URL, dump the database, and not prompt us for any input. Right now it's trying to determine what type of database it is. And it looks like it's found a Microsoft SQL Server database, and it's dumping the database. We have a payment methods table, we have a products table, and we have a users table. The users table contains username and password hashes. So I'm going to take these usernames and put them into a file. Let me go to my editor, create a file called sql.hash, paste in the hashes. I don't need this first column. I'm just going to delete that. Delete these characters at the end. And separate the username from the hash with a colon character. I've done that. I have a file of username and password hashes that I can feed into hashcat. So I'm going to use a hashcat command. Copy that. So this hashcat command will attempt to crack the hashes. I didn't specify a mode, so it's going to try to auto-detect, and it doesn't know what mode it is. It gives you some suggestions. So I'm going to start with the first one on the list, 1410. Let me give it a mode of 1410 and see what happens. And if we're lucky, well, this actually didn't recover anything with this 1410 hash. So let me try. They also suggested 1420. Let me try 1420, see if that works. And we right away get a match. 2 matches. And it's finished. We've recovered 2 out of 4 hashes. Let's see what they are. So we have 2 usernames. We have jpaul and password 123, and we have d.barowski and a password of Kubero. So now that we have some credentials, we can check if those are valid domain credentials. We can start with the first user, jpaul, password 123, and that is indeed valid. Let's try the next user, d.barowski, password Kubero, and that is valid as well. Now, once I get domain credentials, there's a bunch of SMB and LDAP Netexec commands that I like to run. First of all, let me look at the password policy. If we're going to be doing any kind of password spraying, we want to make sure we don't get locked out. And we can see the minimum password length. Well, there isn't one. There's no password history length. There's no password complexity. There's no minimum password age. There's no lockout threshold. So pretty much there is no password policy to speak of. Then I am going to create a list of all the users we have on the system. Again, using Netexec. We can use --users-export and put the users into a file called users.txt. Again, we don't need to do this manually. We don't need to copy and paste these usernames into a file because Netexec will do that for us. Those are our usernames. And then I like to run a bunch of modules. Netexec SMB has a set of modules that enumerate group policy, auto logon credentials, looking for passwords in the group policy files, looking for privileges, checking whether antivirus is enabled, and enumerating to see if we're vulnerable to any CVEs. This command will also list any shares that we have. And we can see we do have a share that we have read access to. Now it's going through looking for logon credentials, XML files that have passwords in them. Sometimes you'll get lucky and you'll find something useful in one of these commands. And now it's looking for privileges that are assigned within the domain through group policy. And when it's done that, it's going to check for any virus enumeration there. And it says that Windows Defender is installed and no CVEs were listed. So I like to look at this list in particular. Let's just look at the word logon. So if we just print out this GPP privileges output again, grep logon. It can show us if any users have logon rights assigned to them. Normally, you'll see users either in remote desktop users or remote management users group, but sometimes there are additional privileges assigned to other users, like Cliff B has interactive logon right, and so does j.dillon. And also we have SVC Jenkins has batch logon right. So that tells us that we could potentially get a shell as SVC Jenkins, and we can get an even better shell with logon right, interactive logon rights, either as Cliff B or as j.dillon. So that's something to bear in mind for the future. And then there's some LDAP modules I like to run as well. Let's go back and copy these LDAP commands. And what this is doing is looking for description fields and info fields and potentially other password fields that might contain passwords. It's also checking to see if ADCS is running and if we have any pre-2K computer accounts that could be exploited. And there's nothing, no descriptions that we care about, and ADCS is not running. Also, I like to run a little command to check if we have any groups that have at least one member in. Groups that you wouldn't normally see. For example, we have remote desktop users. Mike Magnola is a user. Remote management users, we have Cliff Booth and l.thompson. So those three are worth looking at. And we also have a bunch of other groups like protected users. Marco Ibabow. j.bronski is a web app operators user. David Barowski is in IT support. Mike Magnola is in Unix support. Cliff Booth is in directory ops. Andrew Collins support admins. And Marco Ibabow in exchange operators. So some of those are worth looking at in the future. Another thing we can do as soon as we find domain credentials, is check whether we have any ASREP roastable accounts, which we don't. We can also check if we have any kerberoastable accounts. And we do have a kerberoastable account, m.brown. So we have a hash, it should be in krb.hash. So let me look at that. Look at krb.hash. And we'll search for user share word lists rocku. It should auto detect the hash type. If we're lucky, we'll get an additional credential, but it looks like nothing was recovered. So we'll move on and look for SMB shares. We already found that we had SMB shares. What I like to do is run SMB map. SMB map will list every file in every share. If you use the -r for recursive option, -- depth of 9, if you get 9 levels deep, then you got probably a pretty big system there. But generally, I want to list all the files in all the shares. It's good information to have. We can see we have no access to admin $. We have no access to C$. There's not much we can do with IPC $. Here's the net logon share. There's nothing in the net logon share. There's another shares share. We'll get to that in a second. And sysvol. I like to look at sysvol just to see if there's any things like startup scripts, for example. If you look for the letter F in this first column, those are the files. gpt.ini as a standard file, registry.pol, also gpt-temple.inf, another gpt.ini, and gpt-temple.inf. These ones sometimes have files, startup and shutdown, but I don't see anything. And if we look at this shares share, there is a bunch of stuff. It looks like we have a backup folder, IT tickets and tools. If I have a lot of files in a share, what I like to do is dump them all. So I'm going to make a directory for shares. I'm going to go into that directory. And I'm going to run SMB client to create a tar archive of that entire share. So what SMB client will do, you give it the host and the name of the share and the user that you're authenticating as. This -c gives a command to SMB client. It'll run the command and then exit. Command I want to give it is tar. It's going to create a tar archive. C means create, and this is the name of the archive it's going to create. Shars.tar. The asterisk tells it to create an archive of everything. It'll go through all files in the share, hidden files, it'll go through recursively, and you get a complete dump of the entire share. If there's only a few files, I can dump them manually using SMB client. If there's a lot of files, like huge number of files, then I'll probably just use a CIFS mount to access the share. But this one, it's taking its time. Oh, and it's finished. So we can see it did create a tar archive. So I'm going to extract the archive. And there it is. I'm going to get rid of the tar archive. We don't need that anymore. And I'm going to go into VS Code and take a look at the shares that we just dumped. There's a backup folder, IT tickets, and tools. The only thing in tools is, in tools is just a Python, which I don't really care about. Then we have some tickets. Let's go through those. There's a ticket that mentions jenkins.ini file. That's a clue. There's another ticket talking about j.dillon. j.dillon used to be part of the IT team. They removed his auto login credentials. There's still an auto login credential on the domain controller. Something to do with account permissions. Some privileges may still be assigned. So this is going to be a really big clue that we need to go after j.dillon. There's some other notes about printers, software updates, monitors not working. This one looks interesting. Missing ACL permissions for senior DevOps. There's another user. Looks interesting. Cliff.b. Missing access rights for senior DevOps. Incorrectly assigned ACL permissions. That's always good to find. Something to do with a PowerShell script, which may be used to assign required permissions. Okay, so that's good information. The rest of these files, they just don't really look like they contain anything interesting. So let's look at the backup files next. We have a couple of backup files here. Looks like we have a backup of the web directory, a backup of Jenkins, and some event log backups. So this one has a bunch of files in it. So this is telling us that we have, this is the jenkins.ini that it mentioned earlier. It might be worth noting that. And there's also another backup that indicates that we have something running on port 5000, something else to take note of. We go to the Jenkins folder, there's nothing there. inetpub, there's a status, and there's a web root there. Web root is probably the thing we were looking at, the web app we looked at. You can look at that. There's a search. That would be the search function. And here's the SQL injection vulnerability right here. There's no sanitization from the query string that it reads in. There's also a status page as an index file that's empty. IT team, which is just a web page. And there's also a view.aspx file, and this looks interesting. It's reading a file from a query parameter and adding that to the end of this path and reading it. So that is definitely a file inclusion type of vulnerability. So anyway, that's all we have for now from the shares. So we have some interesting stuff there in those shares. So what I'm going to do now, probably be a good time to run BloodHound, get some more information about who these users are that we saw in the shares. So I'm going to run BloodHound. I like to use Netexec to run BloodHound. While it's doing that, let me start BloodHound CLI. But what Netexec will do is it'll basically collect all the information for us. You have to specify the DNS server, which is the IP address of the domain controller. I like to put a timeout in because sometimes these queries can take a long time. And I like to do DCP or TCP DNS queries when I'm operating inside of a VPN. So let me move this output file into the current directory. I'll move this here. And I've started BloodHound. So let me get my password from the config file. There it is. So I'm going to go ahead and run BloodHound. And it was 127001. I'm actually running it on port 8088, so it doesn't conflict with other things. And we have admin, and we had that password here. So we get logged in. There's no data yet, so I'm going to load some from, let's see, YT. There's the file. Cart. I really want it here in shares, but well, that's where it is. It's uploading. Close this, go to the administration file ingest so I can see when it finishes loading. Takes a few minutes and it's analyzing WAL files. That's always a good sign. And it's complete. Let's go to Explorer. So we can look for these users that we found. We had jpaul, and we're going to click this user, click him, mark him as owned. Looks like just a regular user, no special groups. And the other user was d.barowski. Let's kind of look at d.barowski. d.barowski, mark d.barowski as owned. d.barowski, David, is a member of IT support. That's nice to know. And has outbound object control. d.barowski has generic write access. Generic write to 4 users. So we can potentially do a targeted kerberoasting attack. See if we can cover some passwords. So what I'm going to do for that, use LDAP. And I'm going to use this users.txt file that we generated earlier. So we had users.txt SMB, and that's because we're in the wrong directory. Because we're in the wrong directory here. Let's try again. There we go. We have some hashes here. Okay. So those went into targeted krb.hash. So we'll crack those hashes if we can. Crack those hashes. We know jpaul's hash already. And there's j.bronski. That's a new one. We did not have that before. So after we get done cracking the hashes, we have 2 out of 4 that are cracked. And we have jpaul, who we already know, and we have j.bronski, again, with a password. So now that we have another hash, let's go back into BloodHound and looking for Bronski. j.bronski. We'll mark j.bronski as owned. See what j.bronski can do. Member of web app operators. So if we wanted to attack one, attack one of the other web applications, we could probably end up finding something useful for j.bronski. But other than that, there's nothing really that helps us too much. Let's go in and do some cipher queries. We'll look for shortest paths to domain admins. Let's change the layout here. Okay. So we can see that we have m.brown is a member of Exchange operators that can get to this, that has write DACL over all the users. So we should be able to get to domain admins from m.brown. That's worth knowing. And then we also have another path here. We have Andrew Collins can change the password on m.brown, who has allowed to delegate access over the domain controller, which can DCSync to the domain. So if we compromise Andrew Collins, we can get domain admin. And if we compromise m.brown, we can get domain admin. Okay, but how do we get to those users? That's the question. Okay. We go to Collins, see who has control. Inbound control over Collins. Well, Ibabao, which, well, we already know is important. So there's nobody there that's super useful. If we go back to Bronski, so there's nobody there that's really useful, actually. Well, Bronski, we just found Bronski. We can do something with Bronski. Looks like we can change passwords. All these users, we can change their passwords. That looks really useful, actually. So if, oh no, this is Andrew Collins. Okay, let's go back to Bronski. Bronski is a web app operator, but doesn't really control anything, right? So we know we have Bronski. We also know that we have, let's look at some of the remote users that we have. Remote desktop users. We know that we have one member, Magnola. That would be useful to get. And remote management users, we have two members, Thompson and Cliff.b. Either of those would be useful to get to. But we don't really know how to get to those users, right? So a couple of things we can do. We don't know how to get to a user from BloodHound. Sometimes there's stuff that BloodHound doesn't show us. We know we control j.paul. So one thing we can do is use bloodyAD, authenticating as j.paul, and we can see what j.paul can write to. And basically nothing. Just himself and these three groups that everybody can write to. We also know about Barowski. We look at Barowski, see what Barowski. So Barowski can write to Bronski. Barowski can write to Bronski. I think we already have Bronski. But also these other users. Barowski can write to Paul, Rule, Winkler, and Thompson. Remember that Thompson was one of these remote management users. So this is useful. And we can look at Bronski, see what Bronski can write to. Bronski can write to Dillon. Jack.dillon. Jack.dillon was one of these admin users that were mentioned, right? So we know, so let's look at Borowski, get some more detail about who Borowski can write to. If you put detail on the end of this command, it tells you all these attributes are just Borowski's own attributes, so we don't care about that so much. But at the very end, so Borowski can write to l.thompson's user account control flag, which is useful to know. And the other person we had was Bronski. If we put a detail on Bronski, we can write to j.dillon's user account control flag. So if you can do that, you can probably, so j.dillon is also good to know. Now, another way of doing that is, let's say you know there's a user that you're interested in, like Dillon, for example. There's a module in Netexec called DACL read, and that'll tell you who can control this target, which is Dillon. Specifically, if we're looking for user account control rights, you can put that in here too. And Bronski has control over the user account control for j.dillon. If you didn't put the rights GUID in, you may not know what it is you're looking for, but it gives you quite a lot of information. But you can still scroll through this looking for non-admin type users. And here we see, oh, that's read access from Bronski. Keep looking. Eventually we'll find, hopefully, there it is. Bronski user access control. We could do the same thing if we knew that Thompson was somebody we cared about. l.thompson. We could see who controls l.thompson, and again, d.barowski controls l.thompson. So those are useful privileges that we didn't see here. So now that we know that Dillon, we can write to Dillon's UAC. We can use bloodyAD to take a look at Dillon. Let's see what Dillon has. Dillon is no groups and user account control. Nothing special there, right? But we can add the don't require pre-authentication flag to Dillon by using the add UAC command for j.dillon -f, that's the flag, and that's the name of the flag. So now, if we look at Dillon, we'll see don't require pre-authentication. Once you do that, you can just as rep roast. Okay. Let's also look at, I'm going to also look at Thompson as well. Let's look at Thompson. As we saw, Thompson was interesting. Let's see what Thompson has. Oh, Thompson's disabled and is remote management. So we could enable that. We can enable Thompson. Let's just do, let's enable Thompson here. And take a look. Now it's enabled. We can also try we should also try putting on the also try adding this pre-auth flag that we did for Dillon. So what we also could do here is could add this pre-authentication flag to l.thompson. And let's take a look at Thompson. Do quite pre-auth. Okay, so once we've done that, we can try as rep roasting. And we get hashes. Beautiful. So let's try and crack those. Try and crack those hashes. Hopefully, well, oh, we have a hash. So j.dillon cracked, NovaFire 2008, and Thompson did not. So at least we have one more user. So you can go back to here. Let's look for Dillon. We've got Dillon now. Its own Dillon. Okay, so that's good. Good to know. Dillon. What can Dillon do? Dillon has outbound control over the IT Helpdesk. And what can IT Helpdesk do? IT Helpdesk can control, a whole bunch of users. One of those is actually Thompson that we were just looking at, okay? I'm going to set Thompson as the ending node and Dillon as the starting node. So now we can see an attack path to get to Thompson. Dillon is going to become the owner of IT Helpdesk, and once Dillon is in IT Helpdesk, he can change the password for l.thompson. So to get yourself to be the owner of a group, there's actually 3 steps you have to go through. First of all, you have to make yourself the owner of the group. Second of all, you have to give yourself the privileges to add group members. And then third, you add yourself. So become the owner, get the privilege to add members, and then add yourself as a member. So we can do all of this using bloodyAD. So we can do all using bloodyAD. So first of all, we are going to set the owner of IT Helpdesk to Dillon. There it is. The next thing we need to do is add the privileges. So this is a little different because when you do this command, we're going to use an ms LDAP add priv add member. That's the help flag. We need to give it the user distinguished name. We can't just put a SAM account name here. So we have to find those distinguished names. We can get them from BloodHound, or we can just run bloodyAD. There's the distinguished name for Dillon, and we want the other one for the group. Let's put this in here. There's the distinguished name for IT Helpdesk group. Once we have those distinguished names, we can just plug them into the command to add priv member. So now we're going to have privileges to add members. Now all we do is add ourselves as the member of the group. Add ourselves to the group. There it is. We should now be in the group. And the whole point of doing that was because Dillon can now set the password for Thompson. So let's do that. So now Thompson is compromised. We can now click on Thompson, add owned, and let's see if Thompson has anything useful. So Thompson was the one in remote management users. So we probably need to just log in as this user using evil-winrm. So let's do that. See what we can find. Thompson here. And if we're lucky, get logged in eventually. Taking its time. And here we are logged in. Let's look at the desktop user.txt to see if there's a flag here. There it is. So that's the first flag. So now, okay, so we have access as, so now we have access as Thompson, also Dillon. d.Dillon, remember when we looked at d.Dillon earlier, we found that d.Dillon had interactive login rights. So if we can get on as d.Dillon, and d.Dillon do. So we've, yeah, so d.Dillon, so we know about d.Dillon being the help desk person. We should be able to log in as d.Dillon. So the way we're going to do that is use I'm going to start a listener first of all. Let's start a listener and run Penelope to listen for connections on the ton0 interface at this port here. And I'm going to use RunasCs. I'm just going to upload it from my tools directory to evil-winrm. And there it is. Make sure it didn't get deleted. Okay. Now we'll just use RunasCs to get a shell as d.Dillon. There we go. We're going to run a cmd command remote to this address, and there we go. We have a shell. Let's get PowerShell going. Let's go to the home directory. Go out to a home directory here. Move this up. Who am I? First command I run when I get a user. Help desk we know about, nothing special. So there's a bunch of things you can do when you get on a system, but one of the first things to always look at is PowerShell history and recycle bin, all these places where there may be clues. So I'm going to read the PowerShell history for d.Dillon, and it says there is in fact netstat looking for port 22. That is a clue that maybe there's something SSH stuff happening here. So let me look and see. I'm going to see what ports are open. TCP ports. We have a bunch of external ports that we know about. Now, internally, we do have port 22 and 53, and it looks like another server or something running on 22. So if we see SSH that this user seems to be interested in, then it's quite possible that this user is going to have like a key or some way to access SSH. So let's look for a key and we'll see what happens if we find a key. And lo and behold, we do see a key here. IDRSA. But what's really interesting is this key is in the SSH directory, inside of SVC units, inside of home, inside of a root file system. This looks like a WSL directory, so I'm going to go there. Control C doesn't work in Penelope. Let me just start up another shell so we don't have to wait for this to finish. Okay, here it is. Control D to get to the menu. Sessions. Let me interact with session number 2. Okay, here we go. Our shell again. And let's change into, let me go to this directory here, rootfs. Rootfs, oops, get this properly done here. Let's see what we have here. Oh, looks like a root file system. Let's look at root. Go to root, see what's there. Root. Well, more history. Let's look at the history again. We're having luck with the history here. Bash history. And let's see. su minus root. Who am I? Apache CTL start, psorg script, Apache 2 stop, and well, administrator 38. That looks to me like some kind of a password. Interesting. Interesting. We have to see if that belongs to anybody here. Okay. Let's run Netexec and we'll look for passwords here. See if that belongs to anybody. See if anyone has that password. Oh, Andrew Collins. Okay, let's take a look at Andrew Collins. Andrew.Collins. Mark Andrew is owned. Okay, let's see if Andrew Collins can go anywhere interesting here. Andrew Collins, let's go to domain admins. Go to domain admins. I'm ready to let's go to domain admins here. So Andrew Collins. Okay, looks to me like we have some interesting stuff going on here. Andrew Collins can change the password for m.brown. m.brown has delegation rights over the domain controller computer, which can DCSync to the domain. Contains the users, which contain domain admins. So that's basically meaning it's game over. As long as this account's enabled, we just change m.brown's password and impersonate the computer and DCSync. That's basically the attack plan from there on. So let's do that. Let's change Brown's password. Let's do that first. Let me get rid of this. Don't really need that more. Get rid of that. And rid of that. Get rid of this too. Rem anymore. So now we'll just change the password for Brown. That's done. And we are going to impersonate the computer account next. That's kind of crazy stuff. So now Netexec can do impersonation if you have the delegation rights. Save the inner cache. And now let's just use the ticket to get the administrator. So now we can just do a DCSync with that ticket for the administrator. There's the administrator password hash. We can evil-winrm as the administrator. Boom. There we go. And let's see if there's a flag on the desktop. There we go. Root domain compromise. That is it. Once again, this is just the alternative walkthrough. So I would highly recommend going through some of the official walkthroughs and seeing if you can do the officially intended attack path. So I hope you enjoyed it. Thanks for watching.